Alright, so hello and welcome. Another problem we're working on here. This is going to be the contiguous array problem on LeetCode. It's a medium, and we'll see how quickly we can solve it, and hopefully solve it correctly. Last problem I was actually incorrect, and it was not very quick. We figured out what it was, but it wasn't great. It wasn't perfect. Go to binary array nums, turn the maximum length of a contiguous subarray with an equal number of zeros and ones. Binary array nums, turn the maximum length of a contiguous subarray with an equal number of zeros and ones. Oh yeah, that's an interesting question. Interesting. Oh, we gotta think about that. I actually don't have a solution to that. I thought about this before. Contiguous array with an equal number of zeros and ones. And is it just one array, or is it the longest array? The maximum length. Ah, okay. Alrighty. Well, can we go through every contiguous subarray? Well, we can get the sum of every. Oh yeah, you can do that. Actually, that works. Yeah. Okay. I think we can do the same. So we can actually use a hash set to do this. I think, yeah, hash set, hash map rather. I think we can do the same solution that we just did a few moments ago with the contiguous subarray sum, where the sum will tell you how many ones there are, and then that should just be half the size. And so we can just, in the hash set, the key can be the number of ones. See, I'm just thinking. Yeah, I guess it would be. How would this work? You want to have the same number of zeros and ones is equivalent to saying if we calculate the sum over the subarray, we want that sum to be half of the size of that array. And you can say you could save a sequence of the arrays, the previous arrays. I think you need, and that's very likely a spam call, so let me hold on for a moment. Actually, it might not be. Hold on a second. Oh, okay. No, we're fine. Yeah, I just want to make sure we don't want to answer spam calls and don't want to, excuse me, want to answer spam calls but don't want to miss if someone, someone that I know and they call. So what I'm looking for is, yeah, so I think the size, so you could take the size of the array, and what you're looking for is a difference where if you subtract from the size of the array, or half the size of the array, some number k, we'll call it, we have an amount already that's presumably more than k, and what you're going to look in your hash set for is an amount that's the difference between what you currently have and we'll call it, we said k, right? So the size over 2 is k, right? So the difference between what we're looking for, we have, and k, there's some amount. We're looking to subtract that amount, so we're looking for, in the previous arrays, that value. Now, if we are already at k, the value that we're looking at currently, then we can just use that. But otherwise, we want to use our hash set, hash map. And then what we're going to do is, if we find that value, then we're actually going to take the value that's at that stored at that hash map position, and that'll tell us the index. And we're going to decrement between the array position we're at now and that index, and that'll give us the number of elements for this particular contiguous array. And there you go. That would actually, and then that size, we compare that to a largest size that we have so far. And then if we have a larger one, then we take that. So actually, this is pretty easy. We do this in linear time, or relatively easy. We can use the same technique that we were just using just yesterday, which is pretty nifty. Just kind of relearned that technique. There are quite a few output 2. Yeah, quite a few things you can solve, problems you can solve, similar problems you can solve. So int ret 0. I guess 0 is if you don't have any of these values. So we want now, one question is, you can't have an equal number of zeros and ones. It's got to be at least size 2. So just thinking here, when you divide by 2 on the size of the array, oh no, I'm wrong about this. No, I'm wrong. It's not that easy. I take it back. Back to thinking. Incorrect. So, yeah, nope. The problem with this is that even if we subtract and get the right number of ones that we need, the problem that you run into is you just lost a chunk of your of your array, and so you need, yeah, that doesn't work. That doesn't work. Well, I still think a similar approach can work, possibly, but you're basically looping over every possible contiguous array and checking to see if the sum of that array is half of its size, which I think you can do. Excuse me. I'm making all kinds of weird noises because my voice is gone. The question though is, well, we're no longer looking for just a sum. Really, you need a combination that you're looking for, where of the previous sums that you could consider, if you were to subtract. So if you have, if let's say let's let alpha be the size of the array you're looking at now, you subtract some x, we'll say, so you have alpha minus x, and then alpha minus x over 2, let that be k. So you have alpha minus x over 2, or you have k, you have alpha minus x over 2, or it's just k, you have x. You also have another piece, which is the sum over x. We'll call that beta. So there's alpha, there's beta, there's k, there's x. The deal is you need k to be equal to alpha minus beta. So alpha minus beta needs to be equal to alpha minus x over 2. Gives you 2 times alpha minus 2 times beta equals alpha minus x. You subtract alpha, you get alpha minus 2 beta equals x. So alpha is equal to x plus 2 beta. Okay. So that's what you can look for. We said alpha is the size. Yeah. I said alpha is the size of our current array. So you could take that size and you could search for the values you're going to be searching for would be x plus 2 beta, or beta you can calculate. Well, yeah, alpha has to be equal to that number. That number that would get stored would be x is the size, and beta is the number of ones in x. So you would store x plus 2 beta, and what you're looking for is when alpha is equal to x plus 2 beta. So you could use a hash set. But now the tricky thing is, can you extract from there what the value? Well, really just want the size, right? Which is alpha minus beta. So you can extract beta from. I guess you do want to store at that point. Well, that's kind of tricky. I guess you would store the smallest index, probably. You'd want to do it that way. At x plus 2 beta, smallest index you've come across, and then store the smallest index at that point, and then yeah, when you check against it, then you can get what alpha minus beta is, or alpha minus. We said alpha is the size. No, did I get that right? I didn't get that right either. No, I'm wrong about this too. I think, yeah, I'm wrong about this too. The size is some other value. We'll call that y. It's not alpha. Oh, that's so confusing. Let x be the size of the smaller, and y be the size of the larger. Alpha is the number of ones, beta is the number of ones in the other. And that means you want y minus x over 2 to be equal to alpha minus beta. Also, just scratched myself until I cut myself over here until I was bleeding. Whoa! Oh man, my face is that itchy, huh? Wow, is that bad? Let's see. How do we do? Oh, I can't really see from here. You can't really tell. I have to go up to a mirror. But I didn't realize that my face is that itchy. Yeah, it's freak. Scratched myself until I bled. No kidding. Wow. Alright, well. There's that. Wouldn't recommend doing that. So anyway, the part of the issue here is, I think we can still use this technique, but there's a little bit of math involved. I think that's the issue. Let me write it down. It's easier. Doing math in your head is fine, but it can be kind of challenging from time to time if you do it that way. Okay. Excuse me. Alright, so let's do the math. Again, I think this technique works. Hey, see you putting out a ton of videos. The fat prison. Where are you landing a job at? How do you manage this while doing so many videos? It's been a long time since I was here. I hope everything's good. Hello, fat prison. Welcome. Hope it is going well. Welcome. Yeah, I actually, no. I quit my job. Yeah, so I had a job for about 4 years, and then I quit a couple weeks ago about. So now I'm just doing this all day, every day until, well, actually I've been interviewing a lot, but excuse me, until I find employment again, this is what we're doing. All right, so let me try again here. So we have X, we have Y, some part of the array, some other part of the array. We have, we'll call it alpha. So let's do it this way. Let's do alpha is the number of bits in X, and beta is the sum number of bits in Y. We want Y minus X. So if these are indices, it's actually going to be plus 1 over 2, I believe. So we'll take the indice. We can take the size. Actually, that's fine. We'll do this. Let's do X and Y are the size of their respective arrays. That should be equal to half the sum. Should be equal to the sum, which is going to be exactly the sum is going to be beta minus alpha, right? So this is the equivalence that we have between X, Y, beta, and alpha. Yeah, now that's if we have a solution that we're looking for. The tricky thing is, what do we store in our map? Yeah, in our hash set. So we do A, so we can do what do we want? We probably want to store, I guess we store X, so, So Y is going to be equal to 2 beta minus 2 alpha plus X, right? What do we store in our map? Well, we can store this, I guess. See, that's a little confusing. So we can say Y minus 2 beta equals negative 2 alpha plus X. I don't know which one of these should be larger, actually. Why'd you quit? Oh, a lot of different reasons. Oh, it's a long story. But we'll say, oh, it's a lot. Yeah, so many reasons. Well, I guess I should start with I really liked my job. I didn't actually really want to quit. There were like a bunch of reasons for it. So I wanted to leave New York for a long time, and things getting politically charged in New York didn't really help. That was actually one of the reasons I wanted to leave New York. It's quote unquote this idea of voting with your feet. I felt like basically it's pretty hopeless trying to get any kind of political sway in New York. Just the nature of things over there. And there were a lot of things I really don't agree with. Like, to give you an example, my mom mentioned recently that her bill for taxes on her house were like $1,000 a month. It was like $950, I think. Most of that goes to public school. My dad actually lost his home when I was younger because he couldn't pay the taxes on his house. I don't actually know if he paid the whole thing off. I think he did, but even paying the whole thing off, if you lose your job, you could lose your kids could become homeless because they insist on having these very expensive public schools, among other things. Right? There's like a lot of stuff, but so that's like an example of like where politics has been personally for me really difficult. And then, so I don't really like New York for that reason, I guess, because it's like, hey, I can't actually live here because I'm homeless now because my dad lost his business, and you insist on having these expensive public schools, and so he can't afford to live here. So that's kind of one reason. Also, part of that reason is like I actually couldn't live in New York, like it's too expensive. I had a job, but I couldn't live there without a job, and I was like, well, that doesn't give me very much leverage. If there's something wrong at my job or something I don't like or whatever, I'm just kind of a slave because I can't actually live there without keeping my job. So my employer gets like a tremendous upper hand. So I didn't really like that either. So these things are not even necessarily related to my job. I mean, they're related, but they're like ancillary things. And I didn't like, well, there was something I didn't like. I didn't like that they had all these vaccine mandate things going out where they said, hey, we're going to force people to take this experimental drug, basically. And I thought, like, well, I didn't sign up to be a guinea pig here. Like, I'm just trying to, like, feed myself. And I felt like, also felt like for people who didn't want to be forced to do that they should get some support. Like, it really doesn't matter that much for me one way or the other what I do, but I felt like those people should get some support. So, and also I didn't want to take it as well, but I probably would have taken it if they hadn't tried to force me to take it, which is really ironic because I am one of these people that's like, yeah, I'll put my body in the line for science. Like, sure, if it helps other people, why not? But if it's hurting other people because you're forcing it on other people who have adverse reactions, then it's wrong to do that, and then I should actually not take it. So it's kind of this weird. There was that too, and my company was getting ready to force it on people. I don't know what exactly they were doing, but it looked like they were getting ready to do that. So I didn't really want to. I didn't just want to get out. That was one of the things I wanted to get out of that situation too. So where'd you move? If you've already mentioned, I didn't catch it. Sorry. Yeah, I moved to South Dakota. I moved to South Dakota. Yes, sir. Yep, Midwest. And pretty much, I tried to find basically a few things. One, in the middle of nowhere, and two, like I said, so another part of this, like I said, it's like pretty complicated. Are the reasons that I left. Another reason is I became a Christian at one point. I realized the Christian says basically that the Bible says that everybody's evil. Pretty much, there's a lot of verses in the Bible you can find that support the idea that our sinful nature is that we are basically fallen creatures. We're pretty much evil at our core. And so realizing that, I thought, oh, well, if people are mostly evil, and there's a lot of people in cities, I should probably get away from any cities. So like it's not it's not just leaving New York because it's too expensive, but also leaving any urban areas, any cities, any highly populated areas, because those are highly concentrated areas of evil, pretty much. Now there still will be evil elsewhere, but it won't be as concentrated, which hopefully I could handle it a little bit more easily, I guess. Have a little more ability to handle it. So yeah, that's why I wanted to go in like the middle of nowhere, because I was like, well, less evil out there in theory per capita, I guess, or not per capita, but per square mile, maybe. Hopefully, actually, if I add myself to the population, and presumably I am not as evil because I'm a Christian, then it will also reduce the amount of evil per capita. That's a theory, but yeah, obviously I'm pretty evil. So I don't know. I just pray to God on that one. But so yeah, that's why South Dakota, in particular, because it has those properties. I didn't question your belief, but basically you're trying to avoid people, though. Yeah, I mean, in simple terms, yeah. Which I think even a secular person can kind of understand that, like why you'd want to avoid other people. Like it's like, if you go to the city, like you kind of have this sense that like walking around at night alone isn't particularly safe in like New York City. Like if you end up in a back alley in New York City, and at night it's probably not the most safe place to be. Whereas you can walk around at night in like suburbs, and you can walk around at night in places in South Dakota, you'd probably be safe. Actually, I did that a few times already. I'm actually in a I don't want to say exactly which city, but I'm in a city, and I walked around, and I was like, yeah, some people they noticed that I seemed a little skittish because I'm walking around at night alone in a city that I'm not familiar with. And they were like, he seems like he's scared. I don't get it. Why does he seem so scared? I heard them kind of chatter because they kind of called out. They almost practically catcall. I mean, I wouldn't say it's a catcall, but they verbally addressed me when I was walking by. And I guess they were kind of annoyed they didn't like come by and say hello. So pretty friendly city is my point. That's I guess what I'm trying to say is that people are pretty friendly. But I could tell they were, the reason why I kind of kept moving was because I could tell they were up to debauchery, up to no good, that they were drinking and reveling and all of that, which to each his own. Oh, no, I shouldn't say that. No, I shouldn't say that. Scripture says it's Christian, not for a Christian to do. It's wicked to drunkards not inherit the kingdom of God, and revelry is not righteous either. I should clarify. So yeah, there's more reasons too. I mean, like, again, my job wasn't perfect. I mean, there were things that were pros and cons to my job. But I think over time, I've been there for a few years, so like part of it is also like the things you didn't like, they start to weigh on you, and the things that you do like, you start to take it for granted, and so over time you start to become slowly like, oh, I'm not sure if I want to stay, kind of a deal. So I've been there for about 4 years, so there's that. So I've been interviewing quite a bit, and yeah, I don't want to keep going into detail. By the way, this is like, you're getting somewhat of a more polished version of what I would normally say, because I've been interviewing, and that's one of the questions they ask. So I have to practice my spiff it up a bit and make it sound good, make it sound like I'm not some degenerate that just ditched my employer. Yeah, I'm a Christian, so I believe, a man doesn't work, a man doesn't eat. So that's as far as that. As far as like questioning whether or not he's going to work, it's like, well, I take that, I believe that. I think that's true. I think that's true. You can pretend for a while, but like, food's not going to come out of the ground on its own. So what's interesting about this question is, I guess you could store at each point. This looks like x minus 2 alpha. So you could say anytime y minus 2 beta is equal to x minus 2 alpha. So you could store this value. Now the tricky thing here, though, is that this could be a negative number. I guess we don't really care if it's negative or not, because we don't really care very much if it's negative or not. One issue that, well, I guess we could hash to this value also. You can hash, I guess it would be x. Yeah, if alpha is the number of bits, we could just have the smallest value of x for this number, and then we just have to check if. So this is equal to this, which means we really just check if we've already come across y minus 2 beta. Excuse me. And so we calculate y minus 2 beta, check if we've seen it in the map, and then obviously later on we insert this into the map. Now, given we can do something similar to what we did last time, where we know we need to have a size of at least 2 for our array, so we can use previous calculated values to perform that. So I think we can do this. I used to watch your Twitch streams back in the day with you working out a lot, and when you went to, was it Microsoft or Amazon or something? So I kind of know some of your story. Yeah, this is before your Christianity phase. Yeah, no kidding. No. I was interviewing with Google a lot. That was the one that I was interviewing with Google. I interviewed with them twice, and I had plans to interview with them again a little more recently. Actually, earlier this year, we were gonna have me interview again, but a couple of things. One, I didn't feel like I was really good enough for that quite yet. And then I also decided I didn't want to work for Google, even if I got it, which would be great if I got it, but I didn't really want to because of the things they're doing. I just really question it. And I kind of realized, like, my thinking was like, if they say to everybody, hey, we're going to go ahead and start censoring China, we're going to help mainland China, help their government, their government's going to pay us to help censor their people, like, who wants to participate, or do you think this is a good idea? I would be one of those people that say, no, let's not do that. We have enough money. We don't need more. Let's leave China alone, right? Let's refuse on that one. But what I realized was that, like, no, actually, if that hypothetical situation were to occur, they pretty much would just tell me what to do, and then I'd have to decide between doing that or quitting. And I was like, right. I don't actually know if Google is censoring China, but basically the moral character is in such a position where I don't think that's like beyond them to do that. Yeah, so that was kind of what I realized. Was like, oh, I don't think I want to work for this company. I don't think this is gonna work, even though I really wanted to work there. But what can you do? So let's see if we can try to solve this. Let's say, so we'll have different integers, total, and I guess 0, and then in previous totals. The way I did this before was kind of nifty. I did something like this. Int I equals 0, I is less than nums.size, plus plus I, and we kind of got to be, yeah, so this is going to be the total, so this is going to, okay. We have a set unordered map we're going to use. How are we doing on time? 30 minutes. All right, not the best, but we're okay. And this is like the mediums are like typical interview questions, and you want to be able to do them about 30 minutes. Sometimes they take longer, sometimes they take shorter, but you usually get like an hour for your interview, and it should take about 30 minutes if you're like really on top of it. But anywhere from like 30 to 45 minutes is like pretty reasonable. More than that means it's something you probably got to study a little bit more, and then less than that is something that you know very well, and you should focus on something else now. That's kind of what my experience, what I've come across. So yeah, we'll do an unordered map of int, and we're going to say previous sums, or previous vals, we'll say. And what we want to do is say, so if, so it's kind of interesting. We say, we check, so calculate special values. Perform some math. Sort out these values. Just vaguely say something like that. Call it alpha. That's gonna. We said it's gonna be y is the size, so it's gonna be I plus 1, which is the size, minus 2 times the total up to that point. So that's the alpha value. Previous total before we said will be set to alpha, and we want to say a couple things. So if there's two checks, so we want to perform this check before the later check. The later check, we're going to add the previous total. Really, it's the previous alpha value. It's not the previous total. We're going to say, yeah, previous total is actually going to be total. And we're going to say int val is nums of I. We'll come back to that in a moment. Total is going to be equal to plus equals val. So this is either 0 or 1. Alpha is I plus 1 minus 2 times the total. So the previous total is get set to the total, but we're going to actually check in we're say previous alpha is going to be equal to the previous total. No. This is a little bit confusing, but we're gonna the check here that we're gonna perform is whether or not we've seen this alpha value in any of our the hash set that we're building, and then this check here is going to be whether or not we should add this value to the set. Is that right? Is that how that works? Or adding this value to the set? Yeah. So okay. So we do that in one piece though, I think. So we would say, okay, so if previous total, not a previous total, if previous values dot count of alpha, if that's true, then we're going to say int possible is going to be the length. It's going to be previous values of alpha. That should give you the smallest, and we're going to take I minus that. And we're going to say So this should give you this. So if you had 5 and 3, we actually are excluding 3. So it should be 4 and 5. So it should be 2. Yeah, it should be this. And we'll say if possible is greater than ret, and then we update ret. So this is one of the contiguous subarrays that satisfy what we're looking for. And then here we'll say if, and then by the way we can also update. So if it's not there, then previous values of alpha. And actually you really want to say yeah, otherwise you set this to I. Yeah, so the thing is, we don't update this again because we want the value furthest to the left as we're going left to right. So we don't want to update this part again. So we're going to leave it here in this else statement. So even if we see it, we're not going to update it again. We just potentially make use of it. It's something like this, and then it's actually previous values. It's not alpha of I. It's going to be previous total. See, that's the thing. We want to add the previous total, the previous values. That's the thing that we're looking for now. That's totally different. So if we say previous values dot count previous total. Yeah. So we call this previous alpha is going to be, we don't know what that value was though, so that's one of the issues, I guess. 2 times previous total. We'll add this previous alpha. We need to know what index this previous total was at. I think this index is 2 behind necessarily. I think that's the point. Is it 1 behind or 2 behind? I think it's 1 behind. It's I minus 1. Yeah, that's tricky. That's a tricky thing. The way that we did this is we just started I at 1, and we initialized the total to nums of I of 0. Yeah, this is how we handled this last time. There we go. That's the right way to do this. And then so the previous total will be nums of 0 as well. And so we can say, yeah, so this will work. This will work. So we say previous alpha, I minus 1 minus 2 times previous total. If not, then we update it. And we update this with I minus 1. This probably looks really confusing. I don't know exactly know how to explain this very well, particularly well. How are we doing on time? 40 minutes, not great. Our hash map to the hash map. Excuse me. Okay. Call them special alpha values. So now, excuse me, don't forget to return red at the end. Edge case is just 0 initially. I equals 1. Excuse me. Actually, we don't need this because if I is 1, oh no. Yeah, well, the thing is it could be less than 1. It could be 0 technically. Oh, it won't be. Never mind, we're fine. That's okay. Yeah, so in this previous value, then I is not negative. If the count is, so we don't have this previous alpha, then we're going to add it. Now we don't, if we already see this alpha added, then it has the smallest index that we could ever see for it, because this index is only going to increase from there. So we actually can only have to do this once. All right. What if we run this? What happens? Does this compile? Let's start with that. No. Of course. It's always some minor error. Always something. Always something. Okay. 0, 1. So what happens for 0, 1? We say val. So total starts off at 0. Previous total is 0. Val is 1. Total plus equals val. Total is 1. Alpha is I is 1. So it's 2 minus 2 times the total, which we said the total is now 1. So this should be 0 as alpha. Oh, also if the other side, I forgot, that was one more check that we have to do. Check. So if the alpha itself is, this would be 2 times the total, yeah, if alpha is 0. And then we can say, can also do this too. I should use this a little more. I use it from time to time, but you would say ret equals standard maximum of possible in ret. So same deal here. Alpha is 0. You would say possible is I plus 1. It's total size. And yeah, I think we're missing that part too. Yeah, there we go. There's 3 pieces. So it could be, so basically what this is doing, if I could explain in English, is the following. Let me see if we can get some of these other test cases though. Let's just do some randomized test cases. Just a whole boatload of 0s and 1s here. Okay, that's not going to work. I have to be a little more careful than that. Let's get a few 1s, get a few 0s, get a few more 1s, a few more 0s. All right, something like this. Hopefully that's a valid test case. So that's between 1 and 10 to the 5th. Okay. Could also generate our test cases with a what do they call that? With a generate our test cases with a program. So incorrect. Okay, kind of disappointing. Let's find out why. This other case is, so yeah, so the basic idea here is we're keeping track of the sum from left to right, and we're also keeping track of the index from left to right. And what we're doing is we want to check every, from this particular index, every possible contiguous subarray that ends here and traverses to the left. And the way we're going to do that is we're actually going to subtract away all the other possible arrays that from left to right that we've already calculated. And you might say, well, that sounds very expensive, right, to do all that work. Well, we don't actually have to. Because what we can do is we could just take the number that we're looking for, this condition we're looking for, and we can put all of our, put some numbers into a hash map of all of the arrays to the left, such that we can just check to see if the right number we're looking for exists in that hash map, such that this condition we want holds true. Now, I think I got the math wrong. I think that's why it's not working correctly. But in any of the cases where it does work, what we can do is just return in our hash map the index of the array where this condition holds, and we want the smallest index, the one that's furthest to the left, and take the difference between the two indices of the array we're at now, the position we're at now, and index of something that was sufficient when we subtracted it away when we got our condition. Take that difference and compare it to the return value. And if we get a better return value, then that means that's a larger contiguous subarray sum, a largest contiguous subarray that satisfies the condition we're looking for. The condition specifically is an equal number of zeros and ones, which could be rephrased as the size of the array is going to be equal to twice the sum of the array, right? So that's what we're looking for. But the tricky thing is, that's where this alpha value comes from. It's basically take twice the sum and subtract it from what we're looking for. And if you do that, if you calculate this alpha value, we kind of showed the math before that what we want, so the condition we're trying to satisfy specifically is for the smaller arrays, it's you have the whole array, we'll say the size is, the index is, we'll say it's y, and then the sum is beta. So our alpha we're going to call y minus 2 beta, and specifically we're looking for if we take y, and what we want is so there's also some x and some, or not alpha, sorry, call that something else, we'll call it z. We're calling these the alpha values, but let's call it z. So will that alpha be the number, the sum over x as well, right? So x is smaller than y, which implies that alpha is less than beta also. Don't really need that fact, but that's true also. So what this means is that we want some x such that y minus x gives you you're going to subtract away this x smaller subarray right on the left side, and that value should be 2 times this beta minus alpha, where the sum for beta minus the values for alpha gives us the number of ones across our smaller array, and we want twice that sum to be equal to the size of the array. So we want to satisfy this y minus x equals 2 beta minus 2 alpha. And we can separate this into y is going to be plus 2 alpha, or rather y minus 2 beta is equal to x, add x to the right side, subtract 2 beta, x minus 2 alpha. So when these two values are equal to each other, that's when we found what we're looking for, right? Now the tricky thing is, x and y are they the indices or the sizes? See, that's something we need to be careful about. I think they could be the sizes. So that's very tricky. So I'm assuming these are actually the sizes. So actually this previous alpha should be, I think that's the issue. There should be, if there's a +1 here, there needs to be a +1 there. They just need to match. Let's see. There we go. Okay. So that's the issue. And that should be it. That should solve the problem. Hopefully that explanation was sufficient. Yeah, 50 minutes is not great, 50 minutes, but under an hour is acceptable. You really want to go for more like 30 minutes though. Again, this is something I'm kind of getting familiar with, this particular technique to do this, solve these problems like this. Let's see. And we just kind of would want to programmatically place some of these values. Oops. And get randomized test cases. I've been considering building randomized test case, like a randomized test case program that's configurable, so it'll be a lot easier to generate test cases as needed. I think that might save me some time, but not ideally, because you don't really have time to do that during an interview. So you kind of need to wing it a little bit. You kind of need to like come up with some tests that you think might be reasonable and sort of trust what you've coded, I guess. All right, let's go for it and see how we do. Let's see if all that malarkey made any sense. Oh, hey, there we go. Ta-da! Kind of surprised this is so slow, though. I actually think this is probably about as efficient as it gets as far as solutions. This is linear time solution. Maybe there's a way to do this problem that's a lot easier and I don't realize it. This is a pretty efficient solution. I don't know. Let's try again. See if we can get a better number. No, it's slow. Oh man. Wow. I don't know. This is pretty good. This is pretty good, man. This is linear time and linear extra space. It's pretty good. It's pretty clever too. It's a pretty clever approach. I don't know, man. I'm surprised. It might be because these functions. I've said this before that actually these functions can be kind of a nuisance. Sometimes it's better to do this. It's a little bit, I think sometimes it's a little bit more efficient to do it this way. Alternatively, maybe there's a way to use this hash map, like use a vector instead of a hash map. That might be faster, might be more efficient to do it that way. There's another idea. If we change these alpha values, just thinking, is there like a better way to do this? I don't know, man. You could use this alpha, subtract 1, and then the previous total, 2 times the previous total. I don't know. I mean, these are not always positive though. That's the thing. These could be actually negative numbers, which is kind of weird. Hence why I use a hash map. But there might be a way to do this where you use instead of a hash map, you use actually just a set. I mean, a vector rather, not just set, a vector. Can we? Is there a way to do that? I don't know, man. I don't think so. I don't know. I don't have I don't know. That's really tricky. It's so very tricky. We probably should look at the discussion. The discussion would have a faster version, I'm sure. There's gotta be something else we could do here. And this is pretty clever. I like this. It's pretty clever. It's linear. It's relatively fast. The problem with it is that the hash map is slow. I don't know, man. I don't know. Could we maybe maybe we can offset, because we know the most negative value of this is going to be if the total is equal to I plus 1, right? So in the worst case, this could be negative I plus 1, which means it's negative nums.size, more or less. So we can get memory for like basically twice nums.size. And obviously the other direction, if total is 0, this could go all the way up to nums.size, right? So we can go twice nums.size and then translate across the indices from basically add, what would 0 be? 0 would represent 0 would represent negative nums.size minus 1, I guess. Something like that. I'd have to think about exactly how you translate this, but you could translate these values into a vector instead of a hash map, and that vector would be more efficient to operate with. And you could do it that way, and you could say if, and to check the count, you just fill the hash set, or the vector with negative 1s. So if you see a negative 1 there in that index, then we know it doesn't exist to perform this check. And again, to perform this check. Yeah. And then so you can update here, and this, where you would update is actually going to be, instead of, yeah, so our alpha and our previous alpha, you would add, I guess it would be negative I plus 1, or add I plus 1, and that's what you would translate to. Yeah. So you have 2I plus 1 minus 2 times total, that goes to 0. And then the previous alpha you're looking for is the same. And then again, both of these checks, you could just check against negative 1. That might be faster. We could try coding that while we have a minute or two. Yeah, we have a couple minutes. Let's see if we can do that. Let's try this. And, oh, well, the number of numbers, yeah, that's fine actually. We said there's 10,000 of them, so that's okay. We're just going to double that. Oh, wait, previous values is going to be nums.size times 2, negative 1. So the count and then the value. And the thing about this is we actually want to be able to access nums.size. Excuse me, sorry. Excuse me again. So if this total is actually nums.size, which it could be if there's all ones, right? Then subtracting I plus 1, we get negative I plus 1, which is actually nums.size. So negative nums.size. So what I'm trying to say is that we want to be able to access this value itself. We're going to add this. This is nums.size is actually a value we can access. So we're going to add 1 to access that, but also negative nums.size, not just nums.size minus 1 quantity negated, right? Which would be negative nums.size plus 1, which is actually the absolute value of that is smaller than nums.size. So we actually want to add 2 here. So the 0 is going to go all the way to negative nums.size, and the other side is going to go all the way to the top. So twice nums.size plus 1, or twice nums.size. Yeah. So we have both of those. That's a little confusing, but that's how we're going to do that. And then you can say same thing here. Alpha equals twice, 2 times these things. Now I guess you could go so far as to just divide by 2. Then if we're going to do that, so then it's, well, it twice this. It's no longer, so then it'll be equal to I plus 1, no longer 0. But then you divide by 2. You know this is always going to be divisible by 2, but then this is equal to divide by 2, which is confusing. It's very confusing. So that goes back sort of to what we had before. And then we actually don't need twice the size if we do it this way. But yeah, we could just divide by 2 from alpha. Alpha itself is not always, well, we do need to check. We can do, yeah, we could just do this. Alpha and 1 is not odd, and so obviously if alpha is odd, then it's not possible to perform this check. So we can do, yeah, we can just add this extra check here, and then save on the space. Total could be 0, and there's I plus 1, so we do need to have I plus 1. We could divide by 2 everywhere, and then we can do here we can say not equal to -1, and then we can use this, although otherwise so this also works. Both of these would be divided by 2 really. Yeah, and then you would say same thing here. If it's equal to -1, then update it to I minus 1. Something like this should also work, I think. Excuse me. Excuse me. Alright, totally wrong. What happened here? So we say we can modify alpha, subtract 1, multiply by 2, add I plus 1, and set to -1. Okay, so I'm gonna keep whispering because my voice is gone. Previous total equals total. I minus previous total. If this is equal to -1, hasn't been set yet, then we update it. I minus 1. Yeah. This actually, I think this should work. I don't know why. Interesting. Okay. I wonder if there's a problem here. So total is 1, I plus 1 is 2, alpha is 1. Oh, that's the problem. Okay, I see the issue. What is this now, though? This was before. This was 2 times I plus 1. And then, so alpha equals 0. Now it's alpha equals I plus 1. But then you divide both sides by 2. It's alpha. I think it's still alpha equals I plus 1. Yeah. So alpha over 2 equals, but when you multiply it by 2, so I think this part's wrong. So before this was alpha equals 0. Then what happens is you got alpha equals I plus 1. But then you said, so that means that alpha minus I plus 1 equals 0. But then you took alpha and you said subtract I plus, no, divide by 2. So you have alpha divided by 2 equals 0. No, but it's still alpha is now divided by 2. I'd say beta equals alpha divided by 2. Okay, so alpha equals I plus 1. Beta equals alpha divided by 2. What's the relationship between beta and I plus 1? Well, divide both sides by 2. Now beta is equal to I plus 1 over 2. Yeah, that's correct. That was the right idea. I had that right. But that's not right anymore. I think you need to also have I plus 1 modulo 2. Something like this. Something like this. Okay, but we're the wrong answer now. What happened? I think we're missing certain. Well, you could do say 2 times alpha equals I plus 1. That's better, actually. There you go. That makes more sense. That makes a lot more sense. But this is the problem we had before. I forgot what the problem was that we had before. The same one though. I think we're over time now by quite a bit. Yeah, we are. But I'm kind of surprised why this isn't working. This should be a lot faster if it's correct. I minus 1 minus previous total. Previous alpha. So I think the confusing part is this part. We had alpha is 2 times I plus 1 minus 2 times total. And then so we would do 2 times this minus 2 times that. Be 2 times I. But the thing is, it's actually, it's a little more confusing than that. This value, we're doing all kinds of translations here, but this is actually not the correct value. It would be I, so it would be I plus minus previous total, minus 2 times previous total, plus I plus 1, this whole thing divided by 2. That's more of what we're looking for, I think. but this is incorrect. And I'm agitated now. 2 times I would be here, plus 1 divided by 2. But this isn't necessarily correct, because then you get I minus 2 plus a half, really. Which is just confusing now. So, what's going on then? Alright, let's do it this way then. 2 times I plus 1 minus 2 times total. That gives you alpha equals I plus 1, right? And then we can say 2 times I, or just, 2 times I plus minus previous total plus 1. Something like this. I'm going to go back. Let's just see if this is even correct. Let's start with that. No, it's wrong. So why is this wrong and the other was correct? What's happening here? Okay. Why is this suddenly incorrect? Is the question. I don't know. I'm so confused. I don't know what's going on. Why is this suddenly incorrect? If we go all the way back and run this. Okay. If we go all the way back and run this. Oh. This will be correct. Okay. But now if so we're saying I minus 1, I minus 2 times previous total. But I just want to add I plus 1 to alpha, right? Let's do that. Excuse me. Which is add I plus 1 to everything. Including previous alpha and alpha. Let's try that, see what happens. Okay. Add I plus 1 to alpha here. Add I plus 1 to alpha here. Whoops. What did I just do? I don't know. Add I plus 1 to alpha here. Oh, I see. That might be the issue. So I remove the 2 times over here. That might be the problem. Okay, what does this give us? No! No! What is going on? I don't get it, man. This third test case is giving me so many problems. I don't understand what the problem is. I don't understand. This is the same. This is the same. You just get this instead of a map. This is the same. These are all the same things. I guess this is wrong. I don't know. I'm so confused. So confused. Why? Why? Shouldn't this just be... Why wouldn't this work? I don't understand. I don't understand. Should this just be 0? I don't think so. I don't think so. That wouldn't make any sense. No. No. Is it an order of operations thing? Is that what it is? I'm at such a loss here. Let's go all the way back to an unordered map. Back to a state that worked. Alright. From here. This should be just a simple translation. I don't know why I'm struggling so much with this. Okay. We can take alpha and modify that. Oops. And add. Oh, I see the problem. And add. No, that's the issue. I see the problem. Got it. I see the problem. We can go all the way back. Oh, we can go. Alright, I see. I didn't realize that. Okay. We want to add nums.size. That's what we want to add. Not I plus 1. We want to add n to everything. That's the issue. Okay. Got it. Excuse me. Keep coughing in the mic. Sorry. I see the problem now. See the issue. There we go. Okay. Now we can say... Now we can use a vector. Now we can say it's 2 times n plus 2, I think. And then now we can say one or the other. question is, you can add n. Can we? Oh, interesting. Can we modify this somehow? Interesting. It's interesting that this is actually slower and uses more memory. I actually would have expected this to be a little bit faster. Seems somewhat random. How do we change this? Well, this previous alpha we can update, I think. Maybe, I don't know. Can update previous alpha each time instead of using previous total. You might be able to do that, I guess. I don't really know. Yeah, I don't really have a solution, quite frankly, beyond this. This is not much better, though. Yeah, I don't know. I don't know. Seems like the unordered map is actually potentially faster. Oh no, really? What's going on here? Oh, I see. Yeah, well, you have different syntax for the unordered map. For the hash set. I don't know, man. I think it's about as good as I can do it. I don't know. It's pretty interesting that this is faster, though, if we add this extra value here. Why this is faster than why hashing is faster than not hashing, I'll never know. That's bizarre to me. I don't see how that could even be possible. It's not faster, it's random. Okay. Alright, fair enough. Fair enough, but I think we got it. So, alright, sometimes it's faster, sometimes it's not. So yeah, thank you for watching. Man, I wasn't expecting this to take so long, to be so difficult. I don't know, it gets so hard sometimes. So yeah, that's it for this problem. Thank you for watching. I will talk to you soon. Have a good rest of your day. Just thinking if there's anything else I want to say here before I go. I mean, I don't know. That's kind of it. You know, it's just kind of how you do it. I'm trying to think, like, what else to say here. Alright, thank you for watching. Talk to you soon. Take care. Bye. Maybe we could check out the discussion. Maybe we should have done that. We could check out the discussion possibly, but for now, we'll stick with this. Alright.